All right, so I've got the dreaded right after lunch spot, which everybody's just about ready to settle into your chair. Don't put your feet on the tables now, but I know you probably get a little sleepy. And I think there is one little thing, I don't know if you noticed this. The Ale 81, is a great ginger ale, but it does have caffeine in it, if you didn't notice that. So if you had one of those, you're probably going to be okay. But so I wanted to talk about a topic that we wanted to make sure we addressed, and actually Lauren will be up here too, and talk about the same topic with some similar slides. But we're going to talk about acetogenins and pawpaw. So how many out there have kind of heard of the word acetogenin? Great, okay, that's good. Well, we're going to go over a few basics anyway. And, it definitely comes up. Basically, pawpaw is a member of this same tropical family of Annonaceae that contains cherimoya, soursop, a number of other tropical fruits, and it is the only temperate member of that tropical species. But it needs chilling to be able to flower and fruit and grow. But there's a lot of other really widely consumed pawpaw relatives like cherimoya. We used to be able to buy cherimoya actually here in Frankfurt at Walmart, maybe at Kroger. You can still buy it too. It'll come in occasionally. So it is definitely sold and grown at very small amounts in the United States yet. And basically, pretty much all the members that I know of that family contain what is called annonaceous acetogenins. And those are long, unbranched fatty acid chains. And you can see that structure kind of up above. And basically, there's many of these. There's about 50 different unique annonaceous acetogenins. And they are basically compounds with different forms, but they are inhibitors of this complex 1 in mitochondrial chain. And so in your mitochondria, you've got little energy machines going, and there's a step in there called electron transport chain. And these compounds inhibit that. And so it's present for sure in many tissues of the pawpaw. And that's why we say oftentimes maybe mice don't eat around the trunks, right? Because they're kind of bitter compounds, but don't taste real good, and they may not be something the animal wants to eat. And so Jerry McLaughlin, how many people have heard of Jerry McLaughlin here? You see quite a few people too. And Jerry's life's work was really in pharmacology, working at Purdue University as a very distinguished professor there. He developed a lot of different, or identified a lot of different compounds in plants that could have additional uses. And so this is some work that he did identifying these various acetogenins in pawpaw in that family. And basically, if you're still interested, he had quite a group of videos out a while back. When he first retired, he did a circuit. I think he told me he talked like at 60 places in about a year, and talked about the potential for these compounds as anti-cancer compounds. So basically, these are compounds that can have basically anti-tumor, pesticidal, anti-malarial, antiviral applications. And there have been a number of products that actually have been made through extracts from pawpaw. There was a hair lice shampoo, and I think Jeremy still has a bottle of it. Not that he's using it, but he's got a bottle of it up above in his office. Yep. It's a display model. And I don't think it's sold anymore, but it did have a short run because, once again, it has that insecticidal quality. There are some other pesticidal sprays that have been made from it. We actually had a colleague, John Solochek, who worked with this too, trying to use some of these extracts as kind of deterrents or insecticides against, I think it was potato beetle, if I remember right, wasn't it? I think it was potato beetle. cucumber beetle. That's what it was, and it wasn't real effective. In fact, I actually kidded John, and John looks a lot like me, so they used to confuse us a lot on campus. It's kind of funny. I told him it would be more effective if he took this pawpaw and threw it at the cucumber beetle to kill it than the pesticide. So there you go. And that's about the way it was. So, but yeah, there have been different ointments made from it and a number of things. And you can still, I think I removed this slide, but there's I'm going to call it, is it pawpaw? I cannot remember the name of the product now. It's basically a herbal supplement of pawpaw. Celery, yeah, celery. And so basically, it is made out of components of the pawpaw, and it's been sold as a herbal supplement for cancer patients, as maybe once again, it's an herbal product, so not fully tested, but maybe as an anti-cancer compound. So that brings us to a story. So Jerry's work was pretty well known out there, and we knew that different parts of the plant, right, especially the tropical relatives, we knew that there were acetogenins in. And this is Guadeloupe, and actually Guadeloupe was evoked a little earlier today, right, by one of our speakers, but it's kind of just a ways away from, just a little ways away from the U.S. Virgin Islands, and you can see it in the circle up here. And so I do want to point out it's an island nation, so it is kind of isolated. And there was a Lancet article that came out. Lancet's a medical journal that came out, and stated basically that they thought there was a link between Annona fruit and tea consumption and Parkinsonism. And this group actually presented some data that said that there's different forms, and actually Lauren will probably be better at explaining this, but there are different forms of Parkinsonism. There's an atypical form that doesn't really respond to drugs, and and I guess the standard Parkinsonism. And so basically, for whatever reason, usually it's 25% atypical and 75% typical. And in the case there, they found folks who consumed these teas and fruit on a daily basis, that it was the other way around, that 75% had the type that was not very good. And so, as you can see down here, that about 97% of them consumed the herbal tea. So this got folks interested in whether there was a link between these compounds and Parkinsonism. And there was quite a bit of work done then with these tropical relatives of pawpaw. And so basically, there was this, kind of looking at the occurrence of Parkinsonism, other things. I actually dug out some data too that I wanted to make a distinction here. So this wasn't that there's a higher rate of Parkinsonism in Guadeloupe, where a lot of people drink the tea and eat the fruit. It's just that the people who displayed Parkinsonism basically more likely displayed the atypical type, right? So once again, maybe only about 150 people out of 100,000 here in the United States have occurrence of Parkinson, and it's about the same rate, right, in Guadeloupe. So it's not like you're seeing more Parkinsonism. You just saw some of those people displaying worse symptoms who had Parkinsonism. So I want to draw that distinction. And then when some of those folks stopped eating the fruit and drinking the tea, they saw a reversal of their symptoms, which is another key point. So, some things to think about. Basically, as I said, it's kind of a difference between atypical Parkinsonism and Parkinsonism, not that there's a higher rate of Parkinsonism. And then also, it's an island nation, and so it's a different, it's a localized population. There had been some other work done showing some, haploid differences in mitochondrial genes, and so they may have different abilities to metabolize different things, and so respond differently to the fruit than folks in the United States. Now, there was some additional work that was done, and this is a nonicin. I will say that there are several different acetogenins in fruit, like a nonicin and a simicin and bladicin. Doesn't it sound good? I don't know. But there's about 15, according to the group that actually isolated, about 15 milligrams of anonicin in an average fruit, and that was in a cherimoya fruit, by the way. And so basically, they wanted to find out what the amount of that compound actually gets in to the body, and they also wanted to know how much, if they extracted it out of the fruit and injected rats, and this is where we always get in trouble when we're working with test tubes or rats. So if they took anonicin out of the fruit, out of that tropical fruit, and injected the rats, and actually I think Lauren could say better about this, but it's basically pumped in continuously at this rate of 7.6 milligrams per day for 28 days, right? So that was about the equivalent of what one person would eat in a year, and for the rat to get it in that 28 days. And they did observe some of these like tau proteins, which are basically, would be what you might expect in Parkinsonism development. So if you shoot up the rats, you will damage their brains. That's kind of the take home there, but it's a pretty high amount. So here's another fact, though. They also found that only if you were going to eat it, totally different thing. If it's consumed and digested through the digestive tract, then only 3.2% actually gets into the blood. So instead of injecting, the rats, this was consumed. So very low bioavailability. And I guess that's something you think about when you eat something, how much actually gets into your bloodstream, is absorbed in the gut, how much is it degraded as it's moving in, and then how much does your body metabolize. And that's why drugs, even that you take, or medications, break down, your body consumes them. So let's do some math. I know it's kind of heavily math, but here you go. So the question I put to you, so how, if we know this, and I am going to show you some other data, we do know that this pawpaw fruit does have anonicin. It does have that acetogenin in it. And we actually are, here at K-State, are the ones that found that, because Jerry McLaughlin, for whatever reason, he tested the roots, he tested the twigs, the bark and the leaves and the young fruit, and found acetogenic compounds. And then I asked him, but what about the ripe fruit? I never tested that. And so we were the first to try that. And I'll show you some results at the end of this. But we did find it. And so we were the first to publish that it was in the fruit. So we do know it's in the fruit, and then the Louisville group also worked with it at one point. So knowing that, let's do the math. So to get the amount that damaged the rat brain, basically, or neuron tissue, it would be 7.6 milligrams per kilogram. And I used 200-pound person here as just the benchmark. So that's, per kilogram, that's about 90.7 kilograms per person. That means to get that level in the bloodstream, it would take 690 milligrams, right, to get into you. Okay, so that's the first thing to think about. Here's the second thing. So we know that only about 3.2% of what you actually eat actually gets into the bloodstream, right? So that means you'd have to have 21.6 grams, right, which is actually 2,160 milligrams. You'd have to eat a lot of anonicin in that pulp. And so we know from POTS, which was the Louisville group, that there's 0.07 milligrams per gram of pulp, okay? And so that's actually 308 kilograms of pulp. So, and so if you think each fruit that weighs about 120 grams maybe has about 8.4 milligrams of anonicin, that means, and I'll show you it this way, I guess, you'd have to eat 2,600 pawpaw fruit a day for 28 straight days to get that level in your bloodstream. So I really wanted to give the scale of this, how little, and I kind of come back to my example of Dr. Selichek, maybe it's better you throw the fruit at the insect to kill it, because there's very small amounts of acetogenin compounds in the fruit, in relation. And of course, we don't eat it all year round either, but even then, 2,600 fruit which I don't think is humanly possible. Though I've seen these hot dog eaters eat like I don't know how many hot dogs, but I don't think it's possible. And of course, it may vary by bioavailability. There may be some additional acetogenins in the fruit, but anyways, a lot is what it would be. Now, I do want to point out another thing. There are acetogenins in other plants. And so this is avocado. And avocado also has annonaceous acetogenins. Now, they are different structures, as you can see up here. But there are 3 of those. You can see the A, B, and C up here, which have the same mechanism of electron transport chain, inhibiting. And so I'm just saying there's other things out there like, your guacamole that has some of this in, and we're not really talking about that. So, at this point, it takes a lot of fruit for you to get anything near the levels that they were concerned about. But that said, at K-State, I'm always wanting to make sure that we're doing. I would never work with anything that I thought was dangerous, right? And so I am not concerned myself about. I'm more concerned about how many fruit I can eat because I can't get enough than getting less. But I do think that it's a good idea for us to breed for lower acetogenin content. And just so if people are concerned about it, then we could say we've got lower amounts in the fruit. And ironically, the very first time we ran this experiment to see what the levels of acetogenin are in the fruit, sunflower came up as the lowest. And even after all the other pawpaws we've looked at, that's still the lowest one out there right now. And so sunflower is a very low acetogenin selection. And you can see on this list that others are higher, maybe 10-fold, 100-fold higher in activity, but still very low in concentration. So I did go to FDA when we found out about this a number of years ago, and I asked them, what they thought of this situation. And they actually issued a statement email, which is, I guess I found out later it was a little unusual, but they actually sent an email and they said that basically their conclusion was that pawpaw has a long history of food use, and the FDA does not currently have any evidence that pawpaw is unsafe to eat. So that was their edict on it. So I did want to bring that up because, once again, you hear about people do tend to sensationalize things, right? And they want to get in the news. And I know there are inevitably every pawpaw season I get, and Sherry and I get half a dozen emails about neurotoxicity in fruit. And it's also really sad that people use those terms, and some have used them kind of sensationally, I think, to talk about this issue. But there are some high, there are some low. We're going to continue to work with the lower ones as in our breeding, because of that, but also because sunflower is a very productive parent, and I think that's why we're going to continue to use it. But I just wanted to kind of cover that. I know that Lauren's going to also cover this, but basically, do you have any questions or concerns that you want to talk about? Yes, we have someone over here. You want to bring the microphone over to him so that, yeah.
Are you able to correlate perceived bitter taste to acetogenin content? I'm one of those people, I can't stand pawpaws. They taste bitter and rotten to me, but it's really useful. We're screening cultivars in our own farm, so I'll be going down and tasting them and finding the ones that taste okay to me. Can you correlate perceived taste to acetogenin concentration?
We don't know the answer to that. Is there a correlation really between the acetogenin taste and the pawpaw flavor? So at this point, I don't know. Alkaloids would tend to be very highly correlated, and some I do feel like maybe have some alkaloids maybe at low levels, and maybe that's one of the flavors. But at this point, we don't have that data. And it's something I wouldn't mind knowing down the line. I kind of think it probably isn't, though, just knowing about some of the chemistry of taste. I don't know if a waxy that type of compound would really have much flavor. And so that might be a good question for someone who knows more about the actual biochemistry and taste. But from what I do know, I don't think it would have a lot of taste. Other questions out there? Yep, there's one up here in front. Well, there's some thought that maybe there's some temperature sensitivity for acetogenin, although we tried a few experiments with that and didn't really see that. Jerry McLaughlin thought they might not be real heat stable. I think it's possible that we did do some work and didn't really find that, but it is possible. The other thing is that they probably are, their substances would probably be consumed pretty quickly. So like in fermentation, they're probably eaten up by the yeast. You know, that's a problem makes it not a problem with winemaking too, I think. But so, yeah, any other questions? Yeah.
One last comment on the Guadeloupe study. It was a 99 study showing correlation with atypical Parkinsonism with tropical fruit consumption.
Yeah.
Of interest is the more recent information is that paraquat is probably associated with that. And interestingly enough, paraquat was used uniformly on all the fruit plantations in Guadeloupe up until 2007 when it was finally outlawed. So this may have been a paraquat effect more than anything else.
Right. Yeah.
And in case you don't know, paraquat is still legal in the United States, although supposedly in selected instances. It's illegal in most countries of the world, including the European Union, but they all can still manufacture it and sell it to us.
Yeah, and rotenone is also exactly the same mechanism, and there's some thought that they use rotenone maybe to harvest fish, right? They throw the rotenone in and then harvest the fish, but then there's rotenone contamination in the fish tissues that they eat too. So yes, I think that's a really good point, and that could be what's actually leading to some of those, the cases of atypical Parkinsonism, and then whether, maybe it's edged over by having lost the ability to metabolize things. Lots of speculation here, but anyways. So I'll leave it to the next speaker. I think we're out of time, so thank you very much.